All right, welcome. We're gonna look at section 10.8, but I'm gonna start here doing that last one that I messed up. From 10.6, it turns out I wrote it incorrectly. So we have 3x minus 3 plus 1 equals x. Let's move that x to the, or that 1 to the other side. So 3x minus 3 equals x minus 1. Square both sides. So I'm just going to write that again to save myself a step. That cancels. 3x minus 3 equals x squared. That's going to give me a negative 1x. That's going to give me a negative 1x. So this is negative 2x plus 1. Let's move these to the other side. And so we have 0 equals x squared minus 5x plus 4. That's going to factor to x minus 4 and x minus 1, which will give me two answers of a positive 4 and a positive 1. If I plug in 4 right here, I end up with the square root of 3 times 4, which is 12. Take away 3, which is the square root of 9. The square root of 9 is 3 plus 1 more. And if you look back up here, that's supposed to equal what x was. So that is 4. And so 4 equals 4. And that checks out just fine. If I check x equals 1, I have the square root of 3 times 1 minus 3, which gives me 0. The square root of 0 is 0. And so here's an example where I'm left with 1 equals 1. And so both answers actually check. And so you keep both of them. And so that wraps up our 10.6. Let's jump right into 10.8. And that'll be the end of chapter 10. All right. 10.8 is really strange because 10.8 has to do with something called an imaginary number. And so clearly it sounds made up. It's kind of confusing. You can't actually graph an imaginary number because it's not a part of our real number system. I would encourage you to look at the notes. The book actually does a good job also of kind of giving you a little history of like where imaginary numbers lie in the number system. There's a nice little color-coded chart there. But imaginary numbers have practical application that you wouldn't think without really diving into it, which we don't do in our class. So you'll just have to trust me on that one. In 10.1, we looked at this and we discovered it doesn't exist. So you can't take the square root of a negative number. So this has no value. It does not exist in our real number system. And so I'm not quite sure who created the imaginary number, but someone came along and said, well, let's make this number I, and if I allow I to be the square root of negative 1, this will let me manipulate square roots with a negative underneath. If we believe this to be true and we square both sides, well, squaring something takes out that radical, and so I squared is equal to negative 1, which also is going to come into play throughout this lesson. So two things we need to remember. I equals the square root of negative 1, and I squared is the number negative 1 itself. So we're going to simplify, add, subtract, multiply, and divide with these I values. All right, so let's take this same one. I'm going to erase for the moment. Now that we know that we can deal with a negative underneath the radical, what does that look like? Well, step one, always, I would split it. to the positive number, and then break that negative off by itself. So have the square root of -1 separate. This, you know, is just 4, and this is now our definition of what I is. So this becomes 4, and this becomes I, and that's how we're able to simplify. What happens if your number can't be simplified? Well, we still split it, and you just take that negative out and tack an I to the end. So in general, I should have mentioned this a second ago, but I'm kind of too far in now. In general, the I goes in the very back. So if you have two terms, and one is a real number piece and one is the imaginary piece, the real number piece always goes first, and the imaginary number, the I, always goes in the back of the term. So you will see some other books or some examples where they might put the I right there, but the generally accepted part is to put that in the back. All right. What happens when we multiply with negative square roots? So remember, I think it was 10, 3, 10, 4, where if you had something like this, the rule was to just multiply those two numbers underneath the radical and you were done. That rule does not hold true if the numbers underneath the square root are negative. You have to split it from the negative, take that I out is kind of the expression. And so if we have the square root of -4 multiplied by the square root of -25, you don't just multiply those two and come up with a positive 100, because that would ignore the fact that you started with negatives under the radical. So you've got to split it. So we do the square root of 4 times the square root of -1. That's going to give us 2i in the back. We split this. We take that negative out separately. The square root of 25 is 5. The square root of -1 is I. And now we can multiply those two things together. 2 times 5 is 10. I times I is I squared, and I squared is -1, so this becomes -10, which you wouldn't keep the negative piece had you multiplied those two numbers together at the same time first. All right, what else do I have for you? Let's add and subtract. Add and subtract is probably pretty predictable. You're going to add the numbers together. You're going to add the I values together, and that's it. Just remember the I term goes in the back. So 2 plus 8 is 10. 3 and 7 also make 10, and the I goes in the back, and we're done. If I take this same example and change this to a subtract, you just have to remember to distribute the subtraction, distribute that negative. And oddly enough, this is one of the most highly missed questions on the test over chapter 10. So just remember that this is now going to become a -8, and that's going to become a -7i. I'll even write it out for you. We're going to distribute that negative, so it changes both of those signs. So 2 subtract 8 is -6, a +3 and a -7 is -4i. And we just leave that alone. Let's multiply. Very similar to radicals, where you're just going to multiply that through. So, we have to distribute once again. 2 times 9 is 18. Throw the I in the back. 2i times a -3i is -6i squared. but I squared is equal to -1. So let me show you every step. You don't have to show every step on your homework. But I squared is -1, and -6 times a -1 changes that to a +6. But this is not in the right order, so we want to write 6 plus 18i because the I is in the back. Let's FOIL. Let's do 11 plus I and 3 minus 4i. So it's going to work probably as you predict. We're just going to go through the normal foiling pieces. So 11 times 3 is 33. 11 times -4i is minus 44i. 3 times I is a +3i. And I times -4i is minus 4i squared. There's a couple things we can put together here. So I'm going to simplify. It's going to take 2 steps. I'm going to put those two together first. So 33 minus, let's see, 41i minus 4. But remember, I squared is equal to -1. So this piece right here is actually going to change to a +4. So 33 plus 4 more is 37 minus 41i. Let's look at one where we have conjugates because remember I is a radical, so we're going to get to those ones where we have to rationalize the denominator because we cannot have I in the bottom of a fraction. So if we have 5 plus 2i times 5 minus 2i, and we FOIL once again, the I is going to drop out, and so we have 25 minus 10i plus 10i minus 4i squared. Your two middle terms are going to cancel. Remember, once again, I squared is equal to -1. So this is minus 4 multiplied by -1, which changes this to a +4. 25 and 4 make 29. And we don't have any negatives, or sorry, any i's anymore. So this is going to be exactly what we use for our next problem, rationalizing with imaginary numbers. So if you I'll make the denominator just 1. If you have something like that, it's pretty quick to rationalize because the only problem you have here is the I. So you just multiply the top and the bottom of your fraction by I, and that switches it to the top. And then I times I is I squared. And so if this was 5i squared and I squared is -1, then the bottom of my fraction is -5. Let's do one with 2 terms in our denominator. We can do 4 over 3 minus 2i. Remember with the conjugates, whatever that number is, you want to just change it. So it's only the middle one we're going to look at if that was still a little confusing. So we're going to multiply top and bottom by 3 plus 2i. So we're going to FOIL. You can tell I'm going to run out of space here. So I will write the numerator right here, 12 plus 8i over whatever I get. And then I'll show you how we're going to write our final answer in this space right here. So I'm going to take this down. When I FOIL it, I get 9 plus 6i minus 6i minus 4i squared. This is going to become a +4 because -4 times -1. These will drop out. 9 plus 4 is 13. But remember that we need to have it in this form. So if you check your answers in the back of the book, they're going to split it into 2 separate fractions, not one number on the bottom and 2 terms on top. So they're going to write it like so. 12 over 13 plus 8 over 13 with the I probably like right there in the middle. It doesn't matter if you associate, like if you write it like this. I'm not going to make a big thing of it, but try to remember to split it up to the best of your ability. Let's do one more. We're going to have to FOIL on the top and the bottom for our last example. So 6 minus I over 4 plus 7I. All right. Remember, we're just going to change that guy right there. So I'm going to put parentheses around everything. 4 minus 7I, 4 minus 7I. So let's work out the numerator first. 24 minus 42I minus 4I plus 7I squared. This is going to become a -7. So my numerator will be 24 minus 7, which is 17, minus 46I. That's going to go on the top. On the bottom, this part, I'll work that out right there. So 4 times 4 is 16, minus 28I, plus 28I, minus 49I squared. This will change to a positive 49. 16 plus 49 is 65. And so I can write that separately. I can put a 65 right there and a 65 right there and just write it as 2 separate terms right from the beginning. So, all right, I hope these videos have really helped. Let me know where your questions are. This is the end of chapter 10, so that's great. Hooray, hooray. If you've made it this far, we only have maybe 5 lessons left, and I'm going to just hit the highlights of those lessons, so hang in there. Have a great rest of your weekend. If you're, well, it's weekend for me. You probably aren't watching this over the weekend. So have a great day, class. Talk to you later.